Oh. Oh. I just made a rainbow frog, just like the ones you guys made yesterday. And you guys were actually pretty good frog builders. But remember, we didn't just make frogs to make frogs. We made paper frogs to decide how all objects don't necessarily start with energy, but energy can be transferred from one thing or object to another object. And this frog starts with potential energy. The energy is stored when I hold it down. But as soon as I let go, that potential energy transforms into kinetic energy. And there's a law that goes along with that. And it states that all objects don't just get energy. This frog's not just going to start moving. That energy has to come from somewhere, and energy always remains the same. By pushing down on the frog, I actually lose some of my energy and transfer it to this frog. And now the frog has the energy, and it'll jump. And as it jumps and lands, its energy is transferred either as sound or friction. So our goal for today is to understand that all energy in a system stays the same. We call that conservation of energy. So the first word we need to remember is what conserve means. Conserve means to save. That means energy stays the same. It's not created or destroyed. So our law of conservation, remember, conserve means to save, is that energy is saved. Energy doesn't come from somewhere. It has to be transferred from one object to another, or transformed. So let's write that down. Energy is neither created nor destroyed. It transforms or changes from one form to another. And that's from potential to kinetic. But remember, potential means stored. And every time we hear the word potential, we're going to go like this. Because it's like we're storing energy. We're storing air. So potential means stored. Go ahead and underline potential and write stored. And kinetic is when that potential energy starts to move. So we're going to write motion. So right now, your note should look like mine. You translated potential to stored and kinetic to motion. So all energy comes from somewhere else in the system, and potential energy is transformed to kinetic energy. Let's look at a few examples. Our first example, when we eat food, it turns or helps us move. So we can draw a little stick figure running, because remember, we're an animal. Another example, when we push on a spring, like our frog, we might get a moving toy. The potential is turning into kinetic. Our last example, gasoline in a car. That's stored energy, and it helps us move our car wheels. These are just 3 examples of how energy stays the same. It starts as potential, it moves to kinetic, but it never changes. So if you start with 100 joules of energy, how much should you end with? You should end with 100. Energy can't just be created, it can't just disappear, it just changes forms. We're going to talk more tomorrow about what those 7 forms are, but some of them are potential, some of them are kinetic, and the key thing to remember is that energy is always conserved or saved. It doesn't just disappear, it doesn't just get created, it always moves from one form to another. Remember, your job today is to pass or prove it. Be on point, good luck.